Now we discuss other four planets in solar system. We call them outer planet. This one's Jupiter and Saturn, Uranus, and Neptune. Neptune. And they have something in common. Of course, they're much further from the sun. The distance, okay, from the Earth to the sun, we call 1 AU, astronomical unit. And Jupiter is 5 AU, 5 times further. And this 10 times, and this the 20 and 30 times far away. So now because the distance, so they're big but very cold because they receive much less solar energy. And also because far away from the sun, so they have a more chance catch satellite. They have more satellite. We also call the moons. So now when we discuss outer planets, so we call the gases, okay, mostly it's the hydrogen and helium. So these two occupied 99% of the atmosphere. Instead of Earth's atmosphere, we have what? The nitrogen and oxygen. So these four mostly is the hydrogen and helium. And also now the water, methane, and ammonia, they become the solid, become ice. So we call them ice. And the scientists call the Jupiter and Saturn gas giants. And Uranus and Neptune called ice giants. So that's their nickname. So now we can discuss one by one. Jupiter first is biggest one in solar system. The volume is 1,300 times of Earth. The mass is 300 times of the Earth. Well, much bigger, but only 300 times heavier because of low density, a lot of helium and the hydrogen. Because Jupiter is so big, scientists calculated if the mass, the total mass of Jupiter is 80 times more, then what happens? The gravity will produce more energy, squeeze to the center. Then the surface temperature can be very high, more than say 600 degree or 700 degree. At that high temperature on the surface, so then the Jupiter going to glows, give off light. So we say Jupiter is almost a star, almost star. Jupiter has a very small solid core, not very small, small compared to the whole volume. So the size of the core is about size of the Earth, which is small compared to the whole volume. You see this part here we call great red spot, very famous. So this spot here is 2 times bigger than the Earth. Well, the solid core at the center, surrounded by the liquid hydrogen and helium. Again, because low temperature, so the gases become the liquid. So now here's some important information. The distance from the sun is 5 times further than the Earth. So we call 5 AU. Exact distance 775 million kilometer. This is the size number 1 in solar system for the planets. Okay, so the biggest planets. So now take about 12 years circle the sun. We call revolution period. Now the rotation is about 10 hours, pretty fast. the uh, Earth is 24 hours, right? And now the surface temperature is negative 150 degree Celsius, or almost negative 300 degree Fahrenheit. The atmosphere mostly is hydrogen and helium, plus the ammonia and methane. And so far we know 79 satellites. The most famous one is Europa, and the other three found 400 years ago by Galileo. And here's I download some new photos. This is a new one taken in 2012. Well, not even 10 years old. So you can see we're clear the spot again here. This is very important. For example, and because this spot is moving, because the Jupiter rotate. So scientists find this spot come back every 10 hours. So that's how they find the time of revolution equals, the time of rotation equals 10 hours. The rotate around the own axis. So since 1973, a number of spacecraft have visited Jupiter, collect a lot of important information, and take photos. All the evidence tell us how the life seems impossible. Remember the three standards. The first is temperature. It is too low. Second one is oxygen. There's no oxygen in the atmosphere. The third one is what? The third one is liquid water. And we just discussed at a low temperature, all the water become ice. So there's no liquid water, no oxygen, right? And temperature is too low. So now we're going to study one important part. So we're going to connect the physics and astronomy. Okay, how we know the internal temperature of the Jupiter? How we know the temperature inside, not surface? Because we know a planet, every planet, observe solar energy. We call insolation. So now the solar energy is going to convert to the heat. Okay, so now based on how much solar energy come to Jupiter at that distance, 5 AU, scientists calculate the temperature of the surface on Jupiter's surface should be 170 degree negative. Should be negative 170 degree. But now from the measurement, use a different signal, infrared and radio signal. Scientists find the surface temperature is not negative 170 degree. It's negative 150 degree. 20 degree higher temperature is 20 degree higher. Where's the temperature come from? Where's the energy come from? Because conservation of energy, the energy must be come from some resource. The answer is from the center of the Jupiter. So that's how scientists find they estimate the temperature at the center of Jupiter should be 20,000 degree. Okay, compared to the Earth, the center of Earth's temperature is only 6,000. This 20,000. Okay. And matter of fact, half of the energy of Jupiter is come from inside, not like other planets, mostly from solar energy. And for the Jupiter is half and half. So now the Saturn is second biggest planet with very beautiful ring. Uh, and now the Saturn is only one has low density, very low density, less than 1 gram per centimeter cube. This is the density of water. Uh, so the Saturn, if we have enough water, then Saturn can float on the water because of low density. The reason because mostly is the hydrogen and helium. At that low temperature, become liquid. That's on the surface. So surface mostly is liquid of hydrogen and helium. So now let's see some important informations. We have the spacecraft visit and fly by since 1979, collect all kind of informations, important informations. We have same conclusion. Life seems impossible. Temperature too low. No oxygen. Okay, so that's why. No liquid water either. So now the distance is 10 U, 10 times further from the sun. The size and the mass is the number two planet in solar system. Okay, so take almost 30 years, 29 and a half years circles the sun, and the rotations were fast, equals the rotation time of the Jupiter. Take 10 hours. So rotate around the own axis, take 10 hours. Circle the sun, 30 years. And the surface temperature is negative 180 degree, 30 degree below the surface temperature of the Jupiter. The atmosphere, the hydrogen and helium mostly, and totally has 82 satellites on the moons. So now we're going to discuss the other two, and we're going to discuss also Pluto. We know this is not a planet anymore. And now we discuss Uranus and Neptune. So people know them much less than other planets. Why? Because so far away. Uranus, for example. So scientists send a space craft we call Voyagers number 2 left Florida in 1977 and take 9 years before reach the Uranus. So of course not I didn't landing. I just take some photos. Okay, so from 1977 until 1986, so visit Uranus. And when you take a picture, you cannot see very clear of the surface because surrounding by very high dense mason, so light cannot pass through. You cannot see the detail. So the mason reflects the sunlight, and also so far away. It's so dark over there. Okay, one very interesting thing we find is the tilt of Uranus is 82 degrees. So if you recall what we studied in chapter 14, we have winter and summer on the Earth because the angle, the tilt. Okay, for Earth it's 23.5 degrees, right? And for Uranus it's 82. So now see the angle always almost like laid down. That's the Uranus because that big angle, and also because take a long time make circle. So how long? 84 years. So okay, for the Earth, take 1 year circle the Sun. So we have half year, 6 months summer. Okay, well in average, and we have winter every 6 months. Okay, so now the uh, Uranus going to have summer for 42 years and winter for 42 years in average. So 42 years continue darkness and 42 years of sunshine, always at the daytime. Okay, here's information. The size is number 3. Okay, in solar system. So now the distance far away, 20 AU, 20 times further. So because that so far away, the Uranus so far away from the sun, so receive much less energy. So distance 20 times, energy going to be 20 square, 400 times less of solar energy, 400 times less. Okay, so take every 84 years, circle the sun, and the rotation is 16 hours. And because of the far away from the sun, so the temperature even lower, negative 210 degrees. And so far we find 27 satellites around Uranus. And atmosphere mostly is the hydrogen, helium, and very high density of methane. The last one, last planet, we call Neptune. Remember how scientists find it? They calculate first, use law of gravity, then use the telescope, observe this planet, this last one. So anyway, so about the same time, 1983, 3 years after visit Uranus, so the spacecraft visit the Neptune take 12 years. And here is the information. Distance from Neptune to Sun is 30 AU, 30 unit, astronomical unit. So 30 times further compared to the Earth. So much less energy. 30 times further, so energy going to be 1 over 30 square. So going to be 900 times less solar energy. And now, see here's the revolution around the sun. Take 165 years. 165 years. Rotation 16 hours. Now the temperature, surface temperature is negative 200 degrees. Atmosphere, hydrogen, and helium, and methane. Totally 13 satellites. So now, remember Jupiter has a great red spot, and Neptune has great dark spot, pretty dark. And this size almost like size of Earth. And scientists believe that's because the hurricane of the methane ice rotate, make the spot. So you remember the spacecraft Voyager number 2 visit at one trip visit all the outer planets. They had to wait at the right time when the 4 planets lined up same direction. Okay, so it's a very hard journey we call. So a few reasons. Because so cold and so far away, so it's very dark. less solar energy, so dark, so it's harder to take a good picture. This is the best they can do. And also because low temperature, the machines, mechanics and electronics don't work very well. So now also because the big gravity is bigger than the Earth. So then what happens? So this spacecraft is going to be speed up because attracting each other because gravity goes faster, faster, faster. Then the speed can be 10 times faster than the rifle bullet. So it's very hard collect information. And also, will the signal come back to the Earth will take a few hours. That long distance. Okay, so if something happens, you send signal to the Earth space, take 5-6 hours, even at the speed of light. So now we already discussed all the planets. We have 8 of them, 4 inner planet and 4 outer planet. Now Pluto is not anymore. So we discussed this since 2007. So scientists has a meeting. So they decide Pluto is not a planet anymore. So now we call dwarf planet. There are a few standards if you call planet or not. One of them is okay, the planet have to clean up the area. Okay, and Pluto is too small. So Pluto doesn't have enough gravity. So the neighborhood space is not clean enough. So that's one reason. So anyway, remember Pluto is not planet. We call it dwarf planet. And here is some information. Is take distance first. 40 times of the distance. Okay, 40 times of distance from the Earth to the to Sun. We call 40 AU. So it's a 5.79 kilometer. That's almost like a 4 trillion mile. 4 trillion mile. Take 248 years circle the sun. And the rotations were slow. 6 days. 6 days. Because that distance, temperature even lower. Negative 230 degree Celsius. And now the atmosphere mostly is methane and some nitrogen. So far we only found one satellite. So that's the Pluto. It's a dwarf planet, but not only one. So now we have other dwarf planets, and they are 4 of them here: Ceres, Eris, Make, and Haumea. That's 4 other dwarf planets in solar system. Well, this is the end of our chapter. Okay, so we're going to stop right here. This matter will not discuss the rest of the chapter. Thank you.